embedded system is another parameter. We are already told the definition of code design and types of code design, what are the governing things are involved. So one of the most important for embedded system design, sensors. Sensors are most important device. Without sensors, we cannot design and develop any embedded system. Sensor which acquire the physical objects, physical image converted into electrical signal. Sensors are most important. Similarly, controllers. Controllers means input and output can be controlled with the help of controlling. It may be open loop, closed loop feedback systems. We can control the output as well as input. So these are the most important system in case of embedded system. And another actuators. Actuators are basically the major function is output input. Controllers are acts as a by using the actuators. They are specially for controlling the outputs and inputs. Actuators are most useful. And another important area for area reactive system. Embedded system is a specific application, specific region and specific things only we are going to execute it, because very reactive means suppose in humidity is there, humidity sensors we can use it. It is more reactive for humidity, temperature control, speed control. For specific applications only it is most reactive things in case of area reactive system. Real time constant. Real time, almost all embedded system is the real timing ones. It is not a useful for dummy experiments. Real time applications we are very helpful for embedded system. In code design, ISA, application specific instruction, both compiler design as well as hardware optimization. Optimization is one of the important parameter to optimize the device, optimize the hardware as well as the software by using the specific tools. Then what are the code design reconfiguration systems? These are the configuration systems. They are involved so many steps for programming model. The system can be designed, afterwards you can personalize after manufacturing these complete systems. So programming model is another important criteria. In programming modeling contain the first step is sequential modeling. Sequential modeling means it is like a program. You can write it in any language, a sequence of algorithm step by step. Step 1, step 2, step 3. This is treated as a sequential modeling system. It is one criteria in case of program modeling. Another one is data flow graph. Data flow graph is most important. According to the step, we can going to control. This is plus minus. So many process can be control, data flow control according to the step nature of the applications. We are going to control and monitoring, that is known as a data flow graph. According to the data flow of information, if it is a plus all the signals are connected to here, then you can join. So in this way the data flow of information from one point to the another point, which is known as data flow graph. And another important state machine diagram. State machine diagram based on the state. We'll discuss later about the state machine. Simply state machine, which depends on the number of states you are connected. Then another important point is communication model. Communication model is the most important factors, whether it is intercommunication between different devices. It may be synchronous communication or asynchronous communication. You can create both transmitter as well as receiving model. Communication is most important from one point to the another point, input as well as output, and interfacing with several different elements. Then another important criteria is object oriented model. Object oriented means the specific applications object oriented model, that based on the types of experiment, types of the model, you have to design and develop the algorithm, hardware as well as the software. This is known as object oriented model.
3.
Yes. Observe here, state machine model. State machine model, just I am given an instance, I am considering 3 states. state A, state B and state C. Look at this. All the state machines are executing or start its working mechanism based on the conditions. What are the conditions? See, for example, I can take if input is equal to 0 and output is equal to 0, the state is if. Similarly, if input is equal to 1, output is equal to 0, then the state is B. Similarly, if input equal to 1, output equal to 0, state C. Within that system, we can continuously state machine, it is executing within the system, input equal to 1, if output equal to 0, that state is C. Similarly, this process is continuous. If input is equal to 0 and output is equal to 1, it reaches the state A. Within that system, input is equal to 0 and output is equal to 0. Further, it is rotating inside the state A. So, it is a state machine, finite state machine that is continuously moving from one state into another state. So, this finite state diagram, it is directly indicates the flow of information from one form of the system into another form, one state into another state. In this way, state machine can be explained.